Assalamu alaikum. My name is Shafin Rahman and this is my PSM1 research thesis done under the supervision of Dr. Mahezyah Siraj. The title of my thesis is Comparative Analysis of Machine Learning Techniques for Malware Classification. This is the outline of my presentation. First, I'll cover the introduction, then the literature review, then the research methodology, fourth, the research design and implementation, and lastly, the conclusion. This is how the introduction will be delivered. First, the problem background, second, research aim, third, research question, fourth, research objectives, and then the research scope. The problem background. Malwares are a threat to all devices and are increasing every day. There are many types of malwares such as viruses, Trojan horses, worms, ransomware, and more. Usually we rely on antivirus software to detect and remove the malwares from our devices. It is achieved by using a database of identifiable pieces of known file signatures such as strings or behavioral and heuristics analysis to detect suspicious files. The problem is that malware creators can easily edit their code and release different versions of the same virus, thus evading detection. So machine learning has been proposed as a tool to detect malwares. But to train machine learning algorithms, large datasets are needed. But using too many features degrade classifier performance. The aim of this research is to analyze the performance of the classification model proposed by Shafin Rahman in 2015 for malware classification using the Ember dataset. This study asks three research questions. 1. Will the identified feature set obtain the same level of classification when a larger and updated dataset is used? 2. Will selecting a different set of features lead to better accuracy and false positive rates? And 3. Which machine learning technique will perform the best for malware classification? The research objectives are 1. To study the existing malware classification techniques and prepare the dataset for static analysis. 2. To apply supervised machine learning algorithms to classify malwares. And 3. To evaluate and analyze the performance of the classifying model. The scope of this research are as follows. 1. The research will use at least 4 machine learning techniques for the experiment: IBK, random forest, J48, and light GBM. 2. The assessment criteria are based on the true positive, true negative, false negative, accuracy, and ROC curve of the classification. 3. The data used for classification comes from the Ember endgame malware benchmark for research dataset. And lastly, only Microsoft Windows operating system based malwares are in this research scope. The literature review is divided into 4 main parts: related works, PE file format, static analysis, and classification. Related works. In 2001, Schulz et al. Used data mining and multi-naive Bayes algorithm with 97.76% accuracy, but the dataset was far smaller than this study. In 2008, Siddiqui et al. Used RF feature selection and RF classifier with 94% accuracy, but they only focused on Trojans and used n-gram features for classification. In 2009, Shafin et al. Proposed the PE miner, which actually achieved over 99% detection rate, but he used 189 features per file for detection. In 2012, Rahman used data mining and RF to achieve 98.56% detection rate using only 7 features per file. In 2018, Anderson and Roth used light GBM to detect and achieved 98.2% detection rate in the Ember dataset. The PE file format specifies the executable format used by the Microsoft Windows operating system, which includes executables, dynamically linked libraries (DLLs), and font files. The PE data structure is composed of numerous components, including the DOS header, DOS stub, PE file header, image optional header, section table, data dictionaries, and sections. Static analysis. It can be done without actually executing the program, unlike dynamic analysis, which is performed while the programs are running. Static analysis recognizes specific patterns in the file's binary code. A major advantage of static analysis for malware detection is that the malware does not need to be executed. Thus, the analysis can be performed without risk of infection and makes the process faster and easier than dynamic analysis. The classification methods used in this study. IBK, it is a k-nearest neighbor classifier. It is one of Weka's lazy learning algorithms. This technique uses a distance metric to locate k-near cases in the training data for each data point and then makes a prediction using those selected instances. Random forest. It is a collection of decision trees that uses an ensemble learning method for classification. RF mixes numerous classifiers in order to solve a difficult problem and optimize the model's performance. They have three main hyperparameters that need to be set before training. They are node size, the number of trees, and the number of features sampled. J48. It is also a decision tree classifier which uses a straightforward algorithm. To sort an unidentified sample, it makes a judgment based on the attribute values of the available training dataset. After identifying all the similarity values of the new training sample, it recognizes the differentiating attribute. Like GBM, it is also a decision tree classifier, but unlike random forest and J48, it is a gradient boosted machine, which means hard to classify instances are given more weight. It is called light because of its computational power and giving results faster. It takes less memory to run and is able to deal with large amounts of data. The research methodology contains the Gantt chart, research workflow, dataset, justification, and the performance measurement. This Gantt chart shows the workflow I have maintained throughout the semester to complete this project. Research workflow. This research will be done in three phases. Phase 1, review and study existing techniques. Phase 2, experimental design. Phase 3, implementation, analysis, and report. The steps of the workflow are as follows. Formulation of research problems, literature review, finalize the objectives and aims. This is the first phase where the first objective is fulfilled, which is to study existing malware classification techniques and prepare the dataset for static analysis. In phase 2, experimental design, the steps are research design, data collection, data pre-processing, training algorithm, and testing. This phase completes the second objective, to apply supervised machine learning algorithms to classify malwares. And lastly, phase 3, implementation, analysis, and report. The steps are run the experiment, result and analysis, and then report. This phase also achieves two objectives, the second and third. The second objective is to apply machine learning algorithms to classify malwares, and the third objective is to evaluate and analyze the performance of the classifying model. This is the dataset. The Ember dataset was initially released in 2017 and then an updated version was released in 2018. The latest one will be used for this study. It is an open source malware classifier. The features in this dataset are extracted from 1.1 million binary files. It contains 900,000 training samples, of which it contains 300,000 malicious, 300,000 benign, and 300,000 unlabeled. It also contains 200,000 test samples, of which 100,000 are malicious and 100,000 are benign. Performance measurement. The classification model used in this study will be analyzed under this criteria: true positive rate, false positive rate, true negative rate, false negative rate, accuracy, and the ROC curve, of which the area under the curve will be measured. The area under the curve AUC is a summary of the ROC curve and used to measure the performance of a classifier at differentiating between classes. The greater the AUC, the more accurate the model is at sorting between positive and negative classifications. The research design and implementation. It contains several sections: the proposed solution, experiment design, parameter and testing method, installing necessary packages, feature vectorization, feature selection, light GBM model, and train light GBM model. The proposed solution, as discussed in previous chapters, the proposed solution of this study is to use static analysis for malware classification. 4 machine learning algorithms will be used. The dataset to be used is from Endgame. This figure shows the design method used for the experiment of this research. In this experiment, first, feature vectorization will be done. Then, data pre-processing will be done to select the useful features. According to Witten in 1999, irrelevant features can deteriorate performance of algorithms. Thus, after extracting the targeted feature set, each of the 4 algorithms will be trained separately on the training dataset and then tested using the testing dataset. Then the classifier model will be used to run the experiment, and the effectiveness of each method will be determined through the performance analysis. Parameter and testing method. This section discusses how the experiment is conducted step by step. 1. Complete feature vectorization. 2. Run feature selection algorithm to extract the required features from the dataset. 3. Build the classifier models. 4. Train the models based on the selected features from the second step. 5. Proceed with classification using the testing set and trained algorithms. 6. Record the results. 7. Analyze the results and tabulate the data using table, chart, and graph. Installing necessary packages. Provided the dataset files are already cloned from the Git repository, either of these scripts need to be run before installing Ember. Feature vectorization. The raw feature data has to be expanded into vectorized form on disk for model training and into metadata form. These two functions create those extra files. Feature selection. According to Rahman in 2012, the following 7 features can yield a similar result as using 189 features during malware classification. They are debug size, debug RVA, image version, operating system version, size of stack reserve, linker version, DLL characteristics. To build the light GBM model proposed by Anderson and Roth in 2018, this code has to be run. And to train the model, this simple script can be run. Even if the features were not vectorized, it will do the vectorization and train the model. In conclusion, a malware classification model has been proposed and all the classifiers are expected to work with over 97% true positive rates. The first objective has been fulfilled in this study, and further work in PSM2 needs to be completed to achieve the other objectives. Thank you for your time.